You know, we spend pretty much our whole lives inside buildings, but have you ever just stopped to think about the single most important part? It's funny because it's the one part you'll probably never ever see. So today we're going to go underground and meet the unseen hero of every single structure, its foundation.
I mean, really think about it for a second. You see the walls, the roof, all the windows, but what is all of that massive weight actually resting on? I'll give you a hint. It's not just sitting on dirt. So let's dig in and find out what's really going on down there.
So underneath the part of the building you can see, there's what engineers call the substructure. We just call it the foundation. And its job sounds simple, but it is absolutely critical. It has to safely transfer every single ounce of the building's weight into the ground, and then keep doing that without fail for the entire life of the building.
So here's the game plan for this explainer. We're going to follow the whole process, right from the ground down. First, we'll look at how builders even prepare the site. Then we'll get into the huge decision of what kind of foundation to actually use. After that, we'll see how that foundation connects to the floor you walk on. And finally, we'll wrap it all up and see why this hidden world beneath our feet is just so important.
All right, so first things first. The very first step in construction isn't building up, it's digging down. But the second you start excavating, you run smack into two huge challenges that have to be solved before a single drop of concrete gets poured. And those two challenges are about as basic as it gets: water and earth. First, you've got to control all the water that's just naturally in the soil. And second, you have to stop the earth all around your big hole from, well, collapsing in on itself.
Okay, let's talk water. See, the water that's already in the soil is called groundwater, and if you just leave it there, it can seriously damage the new building. The short-term fix is often as basic as it sounds. You stick a sump pump in the hole to get the water out as it fills up. But for a permanent fix, builders have to install special drainage systems to channel that water away for good.
The second problem is just gravity. The sides of that big hole you dug want to fall in, so to prevent that from happening, builders use what's called earthwork support. This can be anything from driving big steel sheets into the ground to using powerful hydraulic systems that literally push back against the trench walls. Okay, so the ground is prepped, it's safe. Now it's time for the main event, choosing and building the foundation itself. And let me tell you, this is one of the most critical decisions in the whole project, and it all happens before anyone even thinks about laying a single brick up top.
So what's the official job description of a foundation? Well, the source material we're using for this really puts it perfectly. Its purpose is to safely transmit the loads of the building to the ground and support those loads for its entire lifespan. Sounds simple enough, but man, it is incredibly difficult to get right. No pressure, right?
Now, this is definitely not a one-size-fits-all kind of deal. A builder has to choose the right tool for the job, and picking that perfect foundation really comes down to three key things: what kind of soil you're building on, how heavy the building is going to be, and of course, the budget. So let's look at the three most common types.
First up, we've got the strip foundation. You can think of this one as the old-school workhorse, especially for houses. And it's pretty much what it sounds like: a continuous strip of concrete that runs directly under the main load-bearing walls. It just creates a solid line of support. And here's the classic trade-off. On the plus side, it's a traditional method. Everyone knows how to do it, which makes it cheap. But the cons are a big deal. Digging all those trenches takes a while, and, more importantly, it means you've got people working down in those trenches. If that soil isn't perfectly stable, it can get really dangerous. That's kind of the hidden risk of the cheapest option.
So, what do you do if you have weak or unpredictable soil where a simple strip just won't work? Well, that's when you bring in the raft foundation. Instead of just a strip under the walls, this thing is one giant solid slab of reinforced concrete under the entire building. It's called a raft because the building literally floats on top of it, spreading its weight out super evenly. It's the go-to solution for tricky ground.
The huge pro here is obvious, right? It totally solves the problem of bad soil. And a nice little bonus is that the slab itself can just become the ground floor, which saves a step. But the cons are just as big. It uses a massive amount of concrete and steel, which makes it expensive. And if that giant slab isn't engineered just right, any crack could compromise the entire building.
All right, our third type is a little more specialized. This is the pad foundation. Instead of supporting a long wall, this is designed to handle a single massive point of weight. Imagine a huge structural column in a big office building. This is just a dedicated concrete pad, and its only job is to spread that one column's immense load into the soil below.
So the main advantage here is speed and power. It's a really quick way to provide incredible support for a very heavy, focused load. The downside is that each pad needs its own custom mold or formwork to pour the concrete into. And there's an even bigger risk. All these separate pads under one building have to be perfectly balanced. If one sinks just a little more than another, it can put incredible stress on the whole structure above.
So, the foundation is in the ground. Great, now what? Well, the next crucial step is to build the ground floor. This is basically the bridge that connects that hidden world of the foundation to the visible building that we all actually live and work in.
And this slide shows the two main ways to do it perfectly. Over on the left, you've got a solid ground floor, which is pretty much a slab of concrete poured right onto the prepared ground. But then on the right, you see a suspended floor. This one actually rests on top of the foundation walls, which creates a little crawl space or a void underneath. The biggest difference really comes down to whether or not it touches the earth. A solid floor is simple, it's strong, and it sits right there on the ground. A suspended floor is held up above it, and that's great for sloped sites or, and this is a huge practical plus, it makes it super easy to run pipes and wires through that empty space. And these days, suspended floors are often built incredibly fast using precast concrete beams that are just craned right into place. So, after all that digging and supporting and pouring, let's just zoom out for a second. Why does this complicated hidden structure matter so much?
Well, it really all comes down to this one idea. The foundation is the single most critical link in a building's entire structure. Everything you see above ground, what we call the superstructure, is constantly pushing its immense weight down. And the foundation is the one and only thing responsible for taking all of that force and transferring it safely into the earth.
If there's one number you take away from all this, it's this one: 100%. Every single pound of that building's weight, plus all of us inside, all the furniture, even the snow on the roof in winter, 100% of that total load has to pass through the foundation. There is literally no other way down. You know, it's an old cliché, but it's a cliché for a reason. You can have the most beautiful design, the most incredible materials in the world, but if the foundation underneath it all is wrong for the soil or it's just built poorly, none of that other stuff matters. A building is, and it always will be, only as strong as its foundation. So I'll just leave you with this final thought. The next time you walk into your house or your office or any building at all, just take a second. Try and feel that massive, silent, unseen hero working away, just a few feet below the floor, holding up your entire world. Thanks for tuning in.